Today the topic for discussion is numerical solution of first order ordinary differential equation by using Euler's method. So this is the third method. The first one is what? Using Taylor series method. The second one is Picard's method, and this is the third one, Euler's method. And this is useful to find the numerical solution of first order ordinary differential equation. So consider this ordinary differential equation of first order dy by dx is equal to fxy with initial condition y x naught is y naught, that is y is y naught and x is x naught, or y is y naught if x is x naught, that is value of x is x naught, y value of y is y naught. Then integrating from y naught to y1. In the Picard's theorem, this is the y naught to y and this is x naught to x, that is in the Picard's methods. So in this method we integrate from y naught to y1 dy and x naught to x1 with respect to x, that is shift this dx to right side, then we have dy is equal to fxy dx. Then integrating, that is y naught to y1 of dy f of xy into dx is integration with respect to x from x naught to x1. And then what is the integration of, here is 1 dy, this is 1 dy, and integration of 1 with respect to y is y from y naught to y1, lower limit y naught, upper limit y1 is equal to integration x naught to x1 fxy dx. And then the value at the upper limit, that is y1, y at y1 means y1 minus y naught is equal to integration x naught to x1 fxy, that is RHS as it is. Then next step, y1 is equal to therefore y1 is equal to y naught, that is shift this y minus y naught to RHS. What do we get? Y1 is equal to y naught plus integration x naught to x1 fxy dx. And we assume this fxy is equal to f of x naught y naught, that is we assume this value of fxy is equal to f of x naught y naught, that is this f of x naught y naught is now constant quantity in the interval x naught x1, in the interval x naught x1, that is the first interval x naught x1. Then we get y1 is equal to y naught plus integration x naught to x1, substitute here f of xy as f of x naught y naught, that is, and this is the constant quantity now dx, and then this is constant quantity, therefore we have this step that y1 as it is, y naught as it is, plus this f of x naught y naught is now constant quantity, therefore it's come out from integration, and then integration x naught to x1 here remains 1 dx, okay, or write only dx, 1 dx or dx. And then integration of 1 is what? Is x with respect to x from x naught to x1, lower limit x naught, upper limit x1, and then value at the upper limit, that is x1 minus x naught, value at the lower limit, the remaining parts are same. And then we assume this x1 minus x naught as h, that is the difference, common difference, and therefore y1 is equal to y naught plus this x1 minus x naught as h f of x naught y naught. This is suppose equation number 2, that is 6.22. And similarly, if we take the next interval, that is in this interval x naught to x1, we have this y1 is equal to y naught plus h f x naught y naught. If we take the second interval, that is from x1 to x2, we assume this f of xy is equal to f of x1 y1, again similar to this, that is in the second interval from x1 to x1, assume f of xy is equal to f of x1 y1, and repeat all this procedure. We have similar formula, y2 is equal to y1, here is y2 is equal to y1 plus h f x1 y1. We have this formula for this interval. Similarly, if you take the third interval, that is x2 to x3, and we are assuming f of xy is equal to f of x2 y2, then we have y3 is equal to y2 plus h f x2 y2. Continuing this process, and we have the general formula yn plus 1, that is here is 2, then here is 1, so yn plus 1 is yn, so here is 2, then here is 1, h into f of xn yn, that is x1 y1, similar to this. So by generalizing this formula, that is if we proceed similar way, then we have the general formula yn plus 1, that is here is 2, then here is 1. At these three places there are 1. So here is n plus 1, then right here is n. If we take yn, if you write the formula for yn, then write here yn minus 1, h f of xn minus 1, yn minus 1. But learn the, remember here take as n plus 1, therefore yn plus 1 is yn plus h f xn yn, n runs from 0, 1, 2, 3. If you substitute n as 0, then we have y1 is equal to y0 plus h f x0 y0, that is this formula. If we substitute n is equal to 0, if we substitute n is equal to 1, then we have y2 is equal to y1 plus h f x1 y1, that is we have this formula. Similarly, if we substitute n is equal to 2, 3, 4, 5, and here is and this is the Euler's formula. This is the formula to obtain the solution of this differential equation. So the question on this topic is what? Discuss the Euler's method. So start writing from here, answer from here, and write this is the general formula, last step. And to obtain the note is what? To obtain the desired accuracy, we need to, here is the correction, to take the value of h very small. That is, if we take h as a small value, then we have the more accuracy, more accurate answer. So first problem on the Euler's method, again this is dy by dx is equal to y minus x divided by y plus x, that is the first order ordinary differential equation with initial condition y is equal to when x is equal to 0, that is y0 is 1. In another form, this condition is what? y0, y in bracket 0 is equal to 1, that is y is 1 if x is 0. Find y for x is equal to 0.1. What is the question? The y at 0 is given, y0 is 1, and we have to find the value at 0.1. And the better, also find the better approximation at 0.1 by dividing the range 0 to 0.1 into 5 steps. That is, first we find the value of y at 0.1 by without dividing the interval. That is direct from 0 to 0.1, directly take this as a one interval, 0 to 0.1. That is, take h as 0.1 in the first part of the example, in the first method of the example. So we solve this example by using two methods. This is the first method, that is without dividing. The value at 0 is given, value of y at 0 is given, and we have to find the value of y at 0.1. That is, the interval is what? 0 to 0.1. And without dividing, now first in the first method we will find the value of y at 0.1 without dividing the interval 0 to 0.1. That is, take h as 0.1. That is from 0 to, we are given the value of y at 0, that is y0 is 1, y0 is 1, and we have to find y at 0.1. Then take h as 0.1, that is without division, we will find the value of y at 0.1. Okay, so dy by dx is this, call it is as f of xy, this right side, dy by dx is equal to f of xy, this is f of xy. X naught is 0, y naught is 1, this is given, and h is 0.1. And if we divide in the next part, if we divide this interval into 5 parts in the next part, in the next method. So here is h is 0.1, that is without dividing the interval, we will find the value of y. Hence the approximate value of y at 0.1 is given by, that is y1, value of y at 0.1. Value of y at 0 is 1, and we have to find the value at 0.1. So y at 0.1 is what? y1 is equal to, the formula is what? y naught plus h f of x naught y naught. This is the value of y1 by using the general formula, that is substitute n is equal to 0, we get y1. So y0 is 1 and y1 is what? At 0.1, value at 0.1, value of y at 0.1 is what? y1 is equal to y naught plus h f x naught y naught formula, Euler's formula. Then what is y naught? Y naught is 1. What is h? H is 0.1. 1 minus 0, f of x naught y naught means this is f of x naught y naught is what? Y naught minus x naught divided by y naught plus x naught, means y naught means 1 and x naught means 0. So the value at x naught y naught means the value at 1 at 0 1, at 0 1, that is substitute x as 0 in this formula and y as 1. So we have 1 minus 0, 1 plus 0, and that is this value is 1.1. So this is the answer of this problem by using first method. This is what 1.1 is the value of y at 0.1 without dividing the interval. Now we divide this interval 0 to 0.1, 0 to 0.1, x naught is 0 and we have to find the value at 0.1. We divide this interval 0 to 0.1 in 5 parts, and so each of length h is equal to length of each interval becomes 0.1 minus 0 divided by 5, because number of intervals are 5, that is b minus a divided by n, similar to trapezoidal rule or Simpson's 1/3 rule or 3/8 rule, that is dividing the interval, and then it is 0.02. If there is an instruction that is divide the interval, then divide the interval. Otherwise, you can solve the problem by using without divide, without dividing the interval. So here is the answer one. This is the one method, first method to solve this example, that is without dividing. And now we divide the interval into 5 strips. Okay, or we divide the interval if the instruction is into 4 strips, then divide in 4 strips or in 2 strips. So what is the length of each interval? H is 0.1 minus 0 by 5, that is 0.02, because the interval is what? The value at 0 is given and we have to find the value at 0.1. So interval is what? 0 to 0.1, that is 0 is a, 0.1 is b, b minus a divided by n, that is 0.02 is the length of each interval. Now we will find the value at first at 0.02, that is the value at 0 is given. Now we have to find the value at 0.2, then at 0.02, then at 0.04, then at 0.06, then at 0.08, and then we get the value at 0.1. That is the answer of the same problem, now divided into 5 intervals. So we have to find y1, y2, y3, y4, and then we get y5. And this y5 is what? The value of y at 0.1. That is the answer of the same problem without dividing and after dividing the interval. So here is the first. Now the approximate value of y at 0.02 is given as y1 is equal to y naught plus h f x naught y naught. So what is y naught? Y naught is 1 and h is now 0.02, and f of x naught y naught means the value of the function f x y is this y minus x divided by y plus x, and now y naught is 1, x naught is 0. So write 1 minus 0 divided by 1 plus 0. This is the value of f of x naught y naught, and that is 1.02. This is y1 and this is the value of y at 0.02. Then the value of y at 0.04 is given by this formula, y2 is equal to, that is put n is equal to 1 now in this formula. In the answer of example, write the general formula that yn plus 1 is yn plus h f x n yn. Then put n is equal to 1, then we have y2 is equal to y1 plus h f of x1 y1. Now y1 is this, now 1.02, h is again 0.02. F of x1 y1 means what? y1 plus x1 divided by y1 minus x1 by using this formula. What is f of x1 y1? Is y1 minus x1 divided by y1 plus x1. That is what? y1 is 1.02 and x1 is what? x1. What is x1? x1 is 0.02. This is x1 now. What is x0? x0 is what? 0. x1 is 0.02. x2 is this, x3 is this, and then x4, x5. Therefore, what is x1? x1 is 0.02. That is the first value of the first value of x is what? x0 is 0, and x1 is 0.2. 0.02. x2 is this, x3 is this, x4 is this, and x5 is this. So here is x1. x1 is 0.02. and 1.02 plus 0.02, and then we have this answer 1.0392. This is y2. This is the value of y at x is equal to 0.04, that is at x2. Then the value of y at x is equal to 0.06 is given by y3. Next formula, that is substitute n is equal to 2, then y3 is y2 plus h of x2 y2, then y2 is this value plus 0.02 in bracket f of x2 y2 by using formula. This is y2 minus x2 divided by y2 plus x2. What is y2? This is y2. And what is x2? x2 is this. This is x1, then this is x2, the values of x, and we have this answer 1.0577. This is y3 at this is y3 means y at 0.06. Then y at 0.08 is given by y formula. Y4 is equal to y3 plus h f x3 y3. Y3 is this. H is 0.02, and then x3 and y3. So what is y3? Y3 is the previous step. Y3 is this, and what is this? Is x3 0.06 is the x3, and then we have this answer. Then last step is what? Approximate value of y at x is equal to 0.1 is given by y5 is equal to y4 plus h f x4 y4, that is substitute n is equal to 4 in the general formula, Euler's formula. Then y4 is this, 0.02 is h. Then f of x4 y4 is what? y4 minus x4 divided by y4 plus x4. Y4 is this, and x4 is what? 0.08. And then we have this answer 1.0927, and this is the value of y at 0.01, not 0.01, it is at 0.1. The value of y at 0.1 is what? 1.0927. So this is by using the second method, that is by using dividing the interval. This answer is what? This is also the same answer, that is the value of y at 0.1 is what? 1.1, and the value of y at 0.1 by using second method is what? 1.0927, and this answer is more accurate than the previous answer, because here is the note. We obtain the accuracy by taking h as small, that is by dividing in more parts, more subintervals, the given interval divided into more subintervals, we get the more accurate answer. So this is the answer of the same problem by using two methods. This is the answer of the same problem with the first method, that is without dividing the interval, and then by dividing the interval 0 to 0.1 into 5 parts. This is the second method. So answer of the same problem by using two methods, and the remaining problems we will see remaining problems on the same method, Euler's method, in the next lecture.